Okay, so a quick one. What we're going to talk about today is a digital multimeter. It's really essential part of tools, and we'll talk through some of the very, very basic features of it. Digital multimeters, they come for about £10. They're very cheap to buy, and I wouldn't recommend buying a particularly expensive one when you start off, just in case you create blue smoke and damage it. So, but you've got some basic functions and some basic features on it. Typically, they've got some connectors and at the bottom, which you'll use to plug your probes into. You've got a common, which is obviously the neutral or the black cable. And then you've got two options on this one. I've got a voltage, and that's voltage, resistance, and milliamps. It's a digital multimeter, so it can measure multiple things. And then the other side, I've got a 10 amp, which is a big chunky way of measuring how much current something's going through. We're going to ignore current today, and the reason being is when you measure current, and this is something you've got to be really careful of. So you've got voltage on this side, which is that little symbol, and you've got straight lines and little dotted lines. That means it's DC. This side you've got AC, so you can measure mains AC. I've got some resistance, I can measure resistance, and I've got some other bits and bats on here. On this one here, where it's got a little a, the ampage, that's where you're measuring ampage. If I switch it to ampage, what it actually does is it will effectively create a short between these two pins. So if you accidentally put it onto ampage, and you put one probe on one side of a battery and another probe on another side of the battery, it would actually create a short, which you get a little spark or a big spark depending on the size of the battery. So when you're testing with these, we're going to go through some of the basic tests. Be very careful not to select any of the ampage ones. Leave them for later. Have a little bit of a Google about measuring ampage. It'll tell you a little bit more about it. But we're going to stick on these. So once you've plugged your cables in, COM and in there, the first thing we'll do is we'll switch it on. As you turn it round, you'll see that something appears on the dial. Now, one of the most common used fault finding, very basic tools is this one here, which I don't know if you can see. We'll zoom in. It's that symbol there. What that is that's continuity and a diode tester. And it sounds very technical, but what it actually does, and what I'll do is I will flick it so that it's pointing towards there. You can see, there we go. It is now saying it's effectively measuring resistance, which is between the two cables. And what continuity does, your continuity test, is you put the two together and you get a beep. So what it's doing is it's checking to see that the circuit is made. And why that's really useful is if you've just made yourself a connector and you're not quite sure why a circuit's not working, you can put one end on there and you can get your connector, put your other end on there, and if you get a beep, it means that has now got a circuit running through it. So continuity, very, very basic, and probably the most commonly used tests for these type of devices. Now, the other thing that's worth pointing out on these is these come with a standard connector, which is these, and these can be quite fiddly when you're sort of messing around with tests. So there are a massive array of different type of probes and connectors that you can actually put on these devices. So I'll just kind of quickly show you some of the ones that are available. So it makes and you can try and get hold of these. You can buy a full kit actually from eBay or whatever, and it can just make continuity testing a little bit easier. So I'll just show you what that means, and it's just so you don't struggle with the standard ones that come through it when there are other options. So you grab a connector. Oh, that's really rubbish, isn't it? Because the connectors I've got now don't fit in. Just pull it under. There we go. Yes, they do fit. I just not took the bloody plugs off. That was embarrassing to say the least. Right, so standard connector in there and red connector in there. There we go. You can tell this is a new shiny cable set because I don't even know how to take plugs out of, which is ridiculously stupid of me. So with the kits, you then come out and you've got the other end. Make sure that you take plugs off, otherwise it may confuse you for a few seconds. And you can plug in different types of testers. So what I'm going to do is, and you can mix and match these ones as well, and I'll just show you what this means. Again, try to keep the colours the same so you don't get mixed up. So here's one example. This one's got a little gripper. I don't know if you can kind of see at the end of there. It grips things, and the other one's a standard probe. So on that last one where I was trying to, keep my fingers on everything, what I could do now is I can grab that gripper and just grab the pin in it. Now if you look on that there, what we're doing is we're grabbing that pin. So this is really handy now, because that's now holding on that really tightly, which means I can grab my continuity tester and just test it on the end like that. Now this is the continuity tester. Typically in the battery is 9 volts, so it means you can touch it. It's relatively safe. I wouldn't recommend getting into the habit of touching cables though when you're testing, otherwise you might not let out blue smoke but do the bad jumpy thing that you often get with electricity. So so that's just a little bit on different types of connectors, and there are quite a few of these. So grabbing yourself a pack with these can make your life quite a little bit easier. Because it just gives you different sort of options. So that was continuity. So continuity is testing to see if you've got a circuit between 2 points. The next thing I'll talk about is then starting to check voltage to see if we've got actually anything that's going through the circuit. Again, similar sort of thing, you can put your connector into there, and I'm going to swap the connectors so you can see different types of connectors. So what I've got now is I've got this little one here, which is a bit for testing batteries. Again, it's set on continuity, so when I press it, I'm getting a continuity. But if we look on there, there's a little minus symbol on there, and on the other side, there's a little plus symbol, okay? So, what I'm going to do is I'm going to change the dial. And this time, let's select something from this range here, which is voltage. So, I'm going to put it around. And what I've got here, as I said to you before, is I've got a little battery, which you can see is 4.8 volts. So and this is ranges, so I can check up to 600 volts, which is ridiculously high, 200 volts, 20 volts. I'm trying to select a voltage range that's higher than what I'm measuring, but not too high, so I don't get to see what it's actually going to come out at. So I'm going to set that to 20 volts. It's on the volt side, so that's good. We're happy with that. Remember what I said before, if you pop it onto this side by accident and try to measure voltage, you'll end up blowing the fuse inside the digital multimeter and you may get a spark. So really be careful about making sure that you keep it on the voltage side. And this little straight line is indicating DC, this is AC. Most batteries that you'll be testing will be DC. Okay, so as we've got it now, we've got it set on 20. It's showing 0 because obviously there's no voltage running through those at all. And I've got these magic little probes. Now I can short those together, there's no danger with that at the moment. I've got positive and negative, and what I'm going to do is just bring those two probes in together and touch the battery, and as I touch across the negative on the negative and the positive on the positive, what I'm actually getting is 5.15 volts. So that's telling me that the voltage is running through the battery. The battery is rated at 4.8. When you charge batteries up, they can go higher or lower, and most components that you're using, like Arduinos, etc., will be quite happy with that sort of voltage range. So don't worry if it's slightly over. Now, if you were to accidentally get these the wrong way around, so you just put the negative on the positive and the positive on the negative, it doesn't do any damage, but what it does do is you can see there, it just gives you a negative reading. So wouldn't worry about that too much, but again, that just lets you do battery testing. Now, when you're looking at using multimeters, those are probably the two main things that you're going to want to test on here. So testing the voltage, and again, if I'm measuring a 24 volt system, I'd just tip it up a little bit to the 200 volts, because that then gives me the ability, the next layer up, so I can measure 24 volts, and same with 600 volts. Typically, what we're building, these are the ones you'll be using, and you'll be using the continuity tester. The only other things that are quite useful, there's a resistance tester there. You can, obviously, with resistors, you've got all of the little colour charts and tables, so you can start to read resistors, but you can very easily check resistors by, again, selecting the relevant. So I'm checking a 1K resistor. I'll probably put it onto that 20K on there. And then I would literally grab my resistor out of the pan and just put it across those two pins, and I'll get a resistance reading. As you go higher up on resistance, you start to get different resistance readings. So you can measure all sorts of different types. So this is up to 200,000 resistors, and this is just to give you a level of how high that is. If I wet my finger and I put connectors, as you know, if you've got wet skin, you will have some ability for current to run through. So now I'm measuring resistance on my wet skin of about 200,000 ohm. So as you can see, it can read some quite low levels or high levels, should I say, of resistance. Okay, so that's what I wanted to really cover off on the digital multimeter. Main things are, get yourself a cheap one to play with, don't need to spend a lot of money, they're all pretty good. Remember about the ampage, remember about the different connectors. You want to make sure you select the right connector, because sometimes they do have different options that sit on there. The dial spins it. The other important thing with these things is turn it off when you're finished, otherwise you end up spending a lot of money on batteries. And then on the back, typically you've got a stand, so you can stand up. There's a single screw there. These typically run on 9-volt batteries in most cases, and then they have a little place where you can clip a standard set of probes. But that's your digital multimeter. Resistance, voltage, and it helps you to diagnose all of your builds. Hopefully that was useful.